carrying a current I as shown. Determine which of the following graph best depicts about the voltage across the coil. So I have not drawn the options down below. Instead of that, we'll find the graph ourselves. Okay, so in the question it is given that a 100 millihenry inductor is in series with a 20 ohm resistor and a current I is flowing through the this inductor, and determine which of the following graph best depicts the voltage across the coil. So we have to find out the voltage across the coil. Okay, so for that, first of all, I have to write the equation of the current. This is the graph of the current. So we have to find out the equation of the current because the current is changing with the time. Okay, before t less than 0, it is 10. It is a constant, and after t greater than 0, it is changing, right? So voltage across the coil V is equal to L into di by dt. We know that this is the voltage across an inductor. Okay. So di by dt, for finding out di by dt, we have to find out the equation of the current. Okay, so for t less than 0, I am talking about current. For t less than 0, I is equal to 10. Okay, for t greater than 0, it is a decreasing slope, so it will be I of t minus y1. It is starting from y1 is 10, right, equal to m into m is the slope is equal to y2 minus y1 divided by x2 minus x1, that is equal to y2 is this one, this is x1 y1 and this is x2 y2. So y2 minus y1 divided by x2 minus x1. Okay, so this is the slope into m into x minus x1. Instead of x, we have t here. In my x1 is 0. Okay, so I of t for t greater than 0 is equal to minus 10 equal to minus 10 raised to by 4, right? 10 raised to minus 3 goes goes up, and it will be 10 raised to 4, excuse me, 10 raised to 4 t. Okay, so I of t is equal to minus 10 raised to 4 t plus 10. Okay, and I of t equal to, if I take 10 outside, I'll get 1 minus 10 raised to 3 t. Okay, so if I write in the equation of I of t equal to 10 for t less than 0 and 10 into 1 minus 10 raised to 3t for t greater than 0. So this is the equation, right? So we have to find out di by dt. So di by dt, what will be di by dt? For t less than 0, it is a constant, so this differentiation will be equal to 0, and for t greater than 0, the equation is minus 10 raised to 4. Okay, for this is for t less than 0 and this is for t greater than 0. Okay, okay, actually we have to find out VRL. Okay, that is VRL is equal to VR plus VL. So the VR equal to, what is VR? VR is equal to I into R, I into 20. So I is actually 10 for t less than 0 and 10 into 1 minus 10 raised to 3t for t greater than 0. For t less than 0, the value of I is 10. So 10 into 20 for t less than 0. And again for t greater than 0, it will be 200 into 1 minus 10 raised to 3 t. Okay, for 0 less than, t less than, okay, this is going up to 10 raised to minus 3 only. So instead of t greater than 0, we can write 0 less than, t less than 10 raised to minus 3. And again we have to find out VL, right? VL equal to L into di by dt. Di by dt is equal to, we have already found that it is 0 for t less than 0 and 10 raised to 4 minus 10 raised to 4 for 0 less than, t less than, 10 raised to minus 3. Okay, so VL equal to, our L is equal to 100 millihenry. So that is 100 into, so VL I am going to write here, 0 for t less than 0, because L into di by dt, di by dt is 0. So for t less than 0, and for t greater than 0, that is 10 into L into di by dt, minus 10 raised to 4 for 0 less than t less than 10 raised to minus 3. So I'll get 0 for t less than 0 and minus 1000 for 0 less than t less than 10 raised to minus 3. Okay, we have to find out VRL. VRL is equal to VR plus VL. So VR, we have already found out VR is equal to 200 for t less than 0 and 200 into 1 minus 10 raised to minus 3t for 0 less than t less than 10 raised to minus 3, right? So VRL I can write equal to 200 plus 0 for t less than 0 and 200 minus 200 into 10 raised to minus 3t minus 1000 for 0 less than t less than 10 raised to minus 3. Okay, that is 200 for t less than 0 and minus 800, 2 into 10 raised to plus, okay. Okay, 2 into 10 raised to 5t minus 800. So for t 0 less than t less than 10 raised to minus 3. Okay, and now let's go to the graph. So it is given in the graph, it is 200 for t less than 0. So I'll draw, this is 200. Okay, and for t equal to 0, what happens when t is equal to 0? This is the case, that is minus 800. So it will start from minus 800 when t is equal to 0. So this is t and this is VRL of t. Okay, so it will be equal to minus 800 for t is equal to 0, and when it is 10 raised to minus 3, 10 raised to minus 3, what happens? Into, instead of t we are going to write 10 raised to minus 3 minus 800, right? So that is equal to minus 200 minus 800, that is equal to minus 1000. So when it is 10 raised to minus 3, it will be minus 1000. Okay, so this is how the graph looks. Okay, VRL graph looks like this. This is not there. Okay, this is a dotted line. So this is how the graph will be looking like. Okay, so that is the answer. Now let's move on to the next question. Let me strike it. The voltage V of t shown in the figure below is applied across a 0.5 Henry inductor having initial current of minus 2 ampere. Find the graph for the inductor current I of t. Okay, so we have to find out the graph for the inductor current I of t. So our V of t is given here. This is the voltage across the inductor, right? V of t is equal to L into di by dt. We know this equation. So di by dt equal to V of t divided by L, right? From I is equal to integral 1 by L V of t plus C. Here instead of C, it is I of 0, that is the initial current across the inductor. Okay, so this is the equation for I. Let's put that in the bracket. So in a in a box. And now what is V of t? For 0 less than t less than 0.5, V of t is equal to 1. Okay, so for that time I of t is equal to 1 divided by, instead of L we have 0.5, right? 0.5 integral 0 to 0.5 V of t. Instead of V of t we have 1 dt plus I of 0 is minus 2. Okay, is equal to 2 into 1 by 2 minus 2, which is equal to minus 1. And for 0.5 to 1. So 0.5 less than t less than 1. Okay, now for 0.5 less than t less than 1, v of t is equal to 0, and I of t, the equation for I of t is equal to 1 divided by 0.5 integral 0.5 to 1, v of t is 0 here, dt plus not I of 0, because now the initial place is I of 0.5, okay. So please don't make this mistake. Please don't write I of 0 here. It is I of 0.5, because in this case the initial condition we are starting from 0.5, okay. So what was I of 0.5? From 0 to 0.5 we have already found it out as it is minus 1. So I of 0.5 is minus 1 ampere, okay. For 0.5 less than t less than 1, it is minus 1, okay. For 1 less than t less than 1 by 1.5, v of t is equal to 1, right. And again I am writing the equation for I of t is equal to integral 1 by 0.5 integral 1 to 1.5 1 into dt plus I of, what is the initial condition? 1. I of 1. So I of t here equal to 2 into 1 by 2 plus I of 1 is minus 1 itself, right. So the answer is 0 ampere. And again lastly 0 less than t less than 2, no sorry, 1.5 less than 0 less than 2, v of t is equal to 0, and I of t is equal to 2 into integral 1.5 to 2 0 dt plus I of 1.5, which is 0 itself. So the answer is 0, and again 2 to 2.5, that is the last one, that is 0 less than t less than, okay, so sorry, not 0, 2 to 2.5, we have v of t is equal to 1 and I of t is equal to 2 into integral 2 to 2.5 1 dt plus I of 2. So the answer is, I'll write on here, I of t is equal to 2 into 1 by 2 plus I of 2. What is I of 2? It is 0, right? So it will be equal to 0, and the answer will be equal to 1, okay, 1 ampere. So I can write I of t's equation like this. For 0 less than t less than 0.5, I of t is equal to, what was it, equal to minus 1, and again for 0.5 less than t less than 1, it is minus 1 itself, and for 1 less than t less than 1.5, it is equal to 0, and for 1.5 less than t less than 2, it is equal to 0 itself, and for 2 less than t less than 2.5, it is 1 ampere, okay. So I'll plot it. I plot it for 0 to 0.5. 0 to 0.5, it is minus 1. And at 0, exactly at 0, it is I of 0 equal to minus 2. So it is starting from minus 2, okay. From minus 2, 0 to 0.5, it is minus 1. That is it. When it reaches 0.5, it is minus 1. and again from 0.5 to 1 it is not changing. This is 0.5. So 0.5 to 1 it is not changing, it is 1 itself, minus 1 itself, and from 1 to 0.5 it is going to 0, right? So like this. That is when it is 0.5 it has reached 0, and from 1.5 to 2 it is 0 itself, and from 2 to 2.5 it is jumps to 1. Okay. So this is the graph. Now let's do this question. In the following circuit, what is the value of a dVr of t divided by dVr divided by dt at t is equal to 0 plus in volt per second? Okay, so that is what is asked here. So for t less than 0, for t less than 0, 10 into u of t will be equal to 0, because u of t is only valid from t greater than 0 to infinity, right? So for t less than 0, if I am drawing the circuit, it will look like this. This will be equal to 0, that is it will be short circuited, and it is 3 ohm, and the inductor will be short circuited for t less than 0, and here also the inductor will be short circuited. And in this case there is no source, then this is IL1 of 0 minus, okay, and this is IL2 of 0 minus. Okay, let this be L1, this is be L2, and this be L1. So the current through the inductor 1 is IL1, and the current through the inductor 2 is IL2. So IL1 equal to IL2, okay, IL of 0 minus IL2 of 0 minus, both are equal to 0 ampere, because there is no source, because 10 u of t is equal to 0 for t less than 0. Okay, so inductor will not allow sudden change in current, so IL of 0 minus will be equal to IL of 0 plus, and IL, this is IL1, and this is IL2 of 0 minus will be equal to IL2 of 0 plus as well. Okay, and if I am writing the equation for t greater than 0, it will be like this. This is 0.5 Henry, this is 0.2 Henry, 3 ohm, 1 ohm, and this is VR of t. Okay, so this is mesh equation, this is mesh 1 and this is mesh 2. So IL1 of t and this is IL2 of t. Okay, the current through this mesh is IL2 of t, and through this mesh is IL1 of t, and I am going to write the mesh equation for the first mesh. This is 10 minus 3 into IL1 of t minus it is equal to L into di by dt. The voltage across the inductor is equal to L into di by dt. That is 0.2 into d IL1 of t divided by dt minus 1 into IL1 of t equal to 0. Okay, and 4. In the question it is asked t is equal to 0 plus. When t is equal to 0 plus, we know that IL of 0 plus is equal to 0 ampere as well. So this is equal to 0 ampere. Okay, so the answer is 10 minus 3 into 0 minus 0.2 into DIL1 of 0 plus divided by dt. Even if IL1 of 0 plus is equal to 0 ampere, doesn't necessarily mean that DIL1 of that is their differentiation is equal to 0. So don't confuse that. Minus IL1 of 0 plus is equal to 0. Okay, from here we will get DIL1 of 0 plus divided by dt equal to 10 divided by 0.2, which is equal to 50 ampere per second. Okay, and write in the next equation, next mesh equation, we'll get okay, 1 into minus 1 into IL2 of t minus IL1 of t minus 0.5 into DIL2 of t divided by dt equal to 0. Mesh 2, this is mesh 1, okay. So for t is equal to 0 plus, this will be equal to 0, and DIL2 of 0 plus divided by dt will be equal to 0 as well, okay. And now, what is VR of t? That is the voltage across the resistor. The current across the resistor is equal to IL1 of t minus IL2 of t, right? The current across the resistor into 1 ohm, okay, I into R. So dVR of t divided by dt is equal to dIL1 of t divided by dt minus dIL2 of t divided by dt. In the question, it is asked for t is equal to 0 plus. So it will be VR of 0 plus divided by dt is equal to dIL1 of 0 plus divided by dt minus dIL2 of 0 plus divided by dt, which is equal to 50 minus 0, which is equal to 50 volt per second. Okay, so this is the answer. Now let's move on to the next question. The H parameter matrix of a, now let's do the next question. The H parameter matrix of a particular network N shown below is 2 ohm, 4 ohm, minus 5 ohm, sorry, minus 5, 2 more, and the circuit is given here. If the power dissipated in the load resistor 4 ohm is 25 watt, then the supply voltage Vs will be, okay. So the power dissipated here in the load resistor, power is equal to V square divided by R, right? The voltage over there is V2, so the V2 square divided by 4, which is equal to 25, and V2 square is equal to 100, and V2 is equal to 10 volt, okay. And now we have to find out what is Vs. So before that, I'll write the equation for the network, the hybrid parameter, and write it as it is. So V1 is equal to H11 I1 plus H12 V2, okay. So H11 is 2 I1 plus 4 V2, and I2 is equal to H21 V1 H21 I1 plus H22 V2. So this is it. And now we have to find out, we have V2 is equal to 10, and V2 is actually equal to minus I2 into RL. So actually it is negative because it is in the opposite direction. I2 is in the opposite direction, okay. So that is equal to 10 equal to minus I2 into, instead of RL it is 4. So I2 is equal to minus 2.5 ampere. And V1 is equal to 2I1 plus 4 into V2, that is 10. That is V1 is equal to 2I1 plus 40, and I1, instead of I1 we have 2.5 equal to minus 5I1 plus 2 into 10. So from here we will get minus 5I1 is equal to 22.5, and I1 is equal to 4.5 ampere. And now what is V1? V1 is equal to 2 into, instead of I1 we have 4.5 plus 4 into 10. So we have 9 plus 40, that is 49 volt. and the question was to find out Vs. So Vs is actually the sum of I1 into 2 plus V1, that is equal to I1, instead of I1 we have 4.5 into 2 plus V1 is 49, right? So that is 9 plus 49, which is equal to 58 volt. So this is the answer. Okay, now let's move on to the next question. In the given circuit below, value of dVr of 0 plus divided by dt is. Okay, so before that we will find out t less than 0. For t less than 0, capacitor will act as open circuit and inductor will act as short circuit. So this is 0. For t less than 0, I of s is 1 ampere. So that is 1 ampere for t V0. It is VR, okay? So VR of 0 minus plus minus Vc of 0 minus again IL of 0 minus. Okay, now we'll find out IL of 0 minus. So IL of 0 minus is same as the current flowing through this resistor, that is 1 ohm. Okay, it is 10 ohm. So IL of 0 minus equal to current division rule, 1 ampere current is being divided between 40 ohm and 10 ohm. So the current through 10 ohm is equal to 40 into 1 divided by 40 plus 10, that is equal to 40 divided by 50, which is equal to 0.8 ampere. So IL of 0 minus and IL of 0 plus will be equal to 0.8 ampere, because there will not be any sudden change in current is not allowed in an inductor. Okay, and now what is the Vc of 0 minus? It is parallel to a short circuited terminal. So short circuited terminal, the voltage is equal to 0. So Vc of 0 minus is equal to 0, as well as Vc of 0 plus will be equal to 0 as well. Okay, now let's see for t is equal to 0 plus, just after time t is equal to 0 plus. Okay, after time t is equal to 0. Okay, that time current will be equal to minus 1 ampere. So it is minus 1 here, and it is VR of 0 plus this will still be 0 volt, and again IL of 0 plus is as it is, will be equal to 0.8 ampere. So this is 40 and this is 10. Okay, so VR of 0 plus will be equal to the current into the voltage across it, current into the what we have to find out the current voltage across our resistor. That is, I'll write the node equation over here. I'll write a node equation that is equal to minus 1 is being divided between 40 and 10 ohm. That is minus 1 equal to VR of 0 plus divided by 40. The voltage over here will be VR of 0 plus as well. So VR of 0 plus divided by 40 plus VR of 0 plus divided by 10. Okay, and taking the LCM we get 4 VR of 0 plus divided by 10 . I'm so sorry. Okay, I'll take the LCM. We'll get VR of 0 plus 4 VR of 0 plus all divided by 40. And from here we get VR of 0 plus is equal to minus 8 volt. Okay, minus 8 volt. And now actually we have to find out dVR of 0 plus divided by dt. Okay, for t greater than 0. Okay, not just after our integer is, sorry, just after 0, it is much after 0. Okay, so for t greater than 0, I'll draw the circuit over here. It will be equal to minus 1 parallel to 40 ohm resistor, and then there is our 10 ohm, that is VR of t is over here, and again there will be capacitor will be acting normal now, and so will be the inductor. Excuse me. So this is Vc of t and this is IL of t. Okay, so I can use a source transformation over here and it will look like this. I'm converting this into a voltage in series with a resistance that will be equal to minus 40 Okay, in the question we have to find out dVR of t is equal to 0 plus divided by dt, right? So first of all I'll write dVR of t divided by dt, that will be equal to d by dt of VR of t, which is equal to d by dt of I into R. VR of t is I into R, right? So 10 into IR of t. Right, this is IR of t. So that is IR of t. And now what is IR of t? Excuse me, this is IR of t. So what is IR of t? IR of t is equal to IR of t is the current flowing across these two resistors, right? So that is the voltage across minus 40 minus the voltage over here, that is Vc of t, minus Vc of t divided by the total resistance is 50, that is IR of t. So I can write VR of t divided by dt equal to d by dt of 10 into, instead of IR of t I can write 40 minus Vc of t divided by 50. Okay, I'll take 1 by 5 outside. We'll get d by dt of minus 40 minus Vc of t. Okay, so what will we get? 1 by 5 into 0 minus dVc of t divided by dt. Okay, so what is dVc? What is the current across the capacitor? IC of t equal to C into dVc of t divided by dt. So instead of dVc of t I can write IC of t divided by C, right? So I can write 1 by 5 into dVc of t. Instead of dVc of t I can write IC of t divided by C. Okay, so that is equal to 1 by 5 is 0.2, that is equal to minus 0.2 IC of t divided by C. So dVR of t divided by dt is equal to minus 0.2 IC of t divided by C. Okay, now the question is, what is IC of t? We have to find out the dVr of t at t is equal to 0 plus. Okay, so for t is equal to 0 plus, what is IC of 0 plus? Okay, IC of 0 plus equal to, we'll have to come back to this circuit and we'll see what is IC of 0 plus. Okay, current flowing over here. Okay, so right in the node equation over here I can write this VR of 0 plus divided by 10, that is the current flowing to the node, okay, equal to IC of 0 plus IL of 0 plus, right? So IC of 0 plus, what is IC of 0 plus is equal to, VR is minus 8, VR of 0 plus we have found it as minus 8. So minus 8 divided by 10 minus IL of 0 plus. What is IL of 0 plus? 0.8, right? 0.8 by 0.8 minus 0.8, which is equal to 1.6 ampere. So IC of 0 plus is equal to 1.6 ampere. So from here we will get, where is it? Okay, is equal to 1.6 ampere. So dVr of 0 plus divided by dt equal to minus 0.2 divided by C. Instead of C it is, how much it is? 2 microfarad.